This is a problem given in NEET 2021 from motion in one dimension. Very interesting problem. Let us see what is given for it. A car starts from rest and accelerates at 5 meter per second square. So let us consider that part of the problem first. That what he is saying that there is a car. Let me try to draw a diagram. Starting from rest but having an acceleration of 5 meter per second square. Then it is said at 4 seconds a ball is dropped out of the window. So it is not dropped immediately but after traveling for some time. So how much time it has traveled? Still having an acceleration of a equal to 5 meter per second square, but it has traveled for 4 seconds. So it definitely cannot be zero. Initial velocity cannot be zero. It will have definitely some velocity. How much is the velocity of that car after 4 seconds? I can use the formula V equal to U plus AT. It is started from the state of rest. Acceleration is given for you as 5 meter per second square for a time of 4 seconds. That is 20 meter per second. So here, after 4 seconds, it is having a velocity of 20 meter per second. Be careful, it's moving on x-axis. So both this velocity and acceleration are on x-axis, right? Now, the part comes like a person sitting by a window in the car dropped a ball. He dropped a ball, right? So what do you mean by ball is dropped? Ball is dropped this way. Be careful when he say drop, its velocity, initial velocity in y direction is zero. See, be careful, its entire velocity is not zero. Dropped vertically down, its velocity along y direction is zero. But parallel, it is having a velocity along x direction as 20 meter per second, right? So at this instant, this ball has velocity along x direction as the velocity of the car itself. Because it is dropped from the car, it will have the velocity of the car itself. But dropped vertically means along the y direction, it has no velocity. What is its velocity? And of course, acceleration at a time equal to 6 seconds, take g equal to 10. That's fine, right? So you need to know velocity after some time, right? So how does the velocity along x direction changes after some time? Let us consider that part, right? After 6 seconds, v along x-axis is again using the same formula u plus at. That stone is having a v or u at after 2 or 4 seconds after dropping instant at this instant as 20. It was not dropped here, it is dropped here after 4 seconds. So it has some velocity along x direction as we have proved. It is no more connected with the car. It is not in the car, so it cannot have a acceleration of the car. It is dropped from the car after a time of 6 seconds, right? So velocity along x direction is 20 meter per second. The same, whatever is there is continue. How about velocity along y direction after 6 seconds? Let us try to find out, right? Okay. Yeah. After 6 seconds, Vy is same formula. Uy plus Ay into t. Uy, it is dropped from the car, so its initial velocity equal to 0. Ay is plus g because it is coming down after a time of 6 seconds. So the value of that uh, need to be careful about this point. This is after 6 seconds. See, this is after 6 seconds from here where 4 seconds is over, right? So here after 6 seconds means as the 4 seconds is already over, I shall write only 2 seconds. Here it doesn't make a difference because 2 into 0 is anyway 0. But here also after 2 seconds because 4 seconds of the journey is already over before the dropping of the stone itself. So G is 10 and into 2, that is 20 meter per second. So the particle will have this car, at this car, in this car, this is having a velocity here and this is also having a velocity here, right? So in the direction of x, it is having a velocity 20. The direction of y also, it's having a velocity 20. So if you draw a diagram for your convenience, this is all. After 6 seconds, Vx is 20 meter per second as we have proved, and Vy is also 20 meter per second. Now I want a velocity, not a component of that. That implies final velocity V bar as Vxi cap plus Vy j cap, right? That is 20 I cap plus 20 j cap or minus 20 j cap, depending on how do you take it, but it's not that worry now because we are not talking about vectors in this problem. So magnitude of the vector is root of x component square plus y component square, that is 20 root 2 meter per second. So of course 20 root 2 meter per second, but there are two options with 20 root 2 meter per second. So we should also find out what is the acceleration so that to conclude that answer. We got only velocity by this time, but we should also need to get acceleration, right? Okay, yeah, acceleration. We are trying to just solve in an organized way. After 6 seconds for the ball, right? So AX is obviously 0 because it is no more connected to the car. The stone is disconnected from the car after 4 seconds. So it's not having acceleration along x direction. Ay is equal to G itself because it is under the influence of gravity, that is 10 meter per second square. So A bar is automatically 0 I cap plus 10 J cap, that is 10 J cap. Magnitude of A is 10 meter per second square. So after 6 seconds, there is an acceleration of 10 meter per second square and a velocity of 20 to 2 meter per second square. That's the answer for the problem. So while we are trying to solve this problem, understand this problem, you have to be very careful about one aspect. He never said velocity of that ball only either along x-axis or only along horizontal or only along vertical. He has broadly asked the velocity. So we shall consider the velocity along x direction as well as velocity along the y direction and find the combined velocity of both of them using a vector notation. You cannot consider only one velocity. Be careful. If you consider any one velocity, there is 20 answer, and you are if you are quick enough to jump to the conclusions, you could have been picked any of these answers which are not actually correct. Even after coming to that part, here also there is acceleration 0. So if we are still in the path of horizontal and if you are looking in that way, the stone is disconnected from the car, so its acceleration is 0, then you are still having a chance of picking up this answer also, which is not correct, right? So be careful while you are correcting this, while you are finding an answer for this. It's a good question which explains you a few concepts in one-dimensional motion at a basic level. That's it for watching.